Structural Analysis 2, Chapter 8, Deflections using Energy Method. Let's solve an example, the virtual work method frames. So in this example, we have a frame with a fixed support at A and a horizontal part like BC, which handles a distributed load of 400 pounds per feet. We want to know what is the horizontal displacement at point C. So by applying the virtual work method, we can apply a 1 unit load, 1 pound unit load in the direction of horizontal displacement at C, and then 1 times delta C horizontal is equal to integration of small m capital M EI times dx. First of all, if we just develop the real moment, which is the capital M, then proceed to calculate the small m effect of virtual one, then replace in the main formula to get the horizontal displacement at C. So the effect of real moment, cut this real structure. For example, first of all, converting the distributed load of 400, the intensity times the length is 400 times 830, 200 is distributed load conversion to a concentrated load applied at the center. And if we just cut our beam through like x bar from C and develop the equation for moment, you can easily see summation of moment about x goes 0. It just gives us the equation of mx bar moment at x bar at part 1, if we call it part 1, and part 2, real moment is is equal to 200 x1 squared. And as soon as we have the equation for calculating moment and just move to the second part, summation of moment about A goes 0, it just gives us including moment at A fixed support has a moment, we just include it in the equation. So negative MA plus 3200 times 4, which is this distance, this equation, this force times arm is a moment, is equal to 0, and it just gives us MA is equal to 12,800 pound feet. That's the unit, pound feet. So far we have the equation of the real moment, part 1 and part 2. We need to do the same process for our structure in the effect of a virtual moment. So virtual load. So if we remove all the forces on our structure, again, mx ma is equal to this one. If we cut our structure by the length of x or x2 for the second member, it just gives us the same amount of moment at A because there is no disturbing force here. There is only vertical force at A, which has no conflict and it doesn't create any moment at X. So as soon as we release all the forces and apply one load, direction of our displacement, horizontal displacement, and cut the section through first part, it just gives us m1, small m is the effect of virtual moment, that is 0, and ma, if you calculate it for the second part, you cut it through for the second, it just gives you summation of moment about x2, which is this one is x or x2, it just gives us mx2 is equal to 10 minus x2. Then you have ma equal 10 force on structure, virtual moment gives you the equation for m1 and m2. Then we need to have our structure with both moments, virtual one, and this is the effect of real moment, m1, m2, part 1 for part 2, also m1 for part 1, part 2, virtual one. And then by just having the equation of 1 times delta is equal to 0 times L small m capital M or EI times dx. So 1 delta C horizontal, just take EI like a constant out of integration is equal to integration from 0 to 8, which is this member. And because the small m is here, 0 small m times the capital M just gives us a, just make it 0 plus 0 to 10, which is the length of vertical member, 10 minus x2, which is the small m, times 12,800, which make it like multiplication of this equation. And if you do so, it just gives you 640,000 pound times feet cubed over EI, which if you simplify the unit of this one with EI, it just gives you a number feet. And definitely it's very small number. Thank you. We'll solve more problems with visual frames in next videos. Thank